Hey guys, so today's lesson we're going to actually talk about rectilinear shapes and how we can find perimeter of a rectilinear shape. The first thing that we have to do though is figure out what a rectilinear shape is. So a rectilinear shape is a shape, mostly a polygon, that is made up of rectangles as shapes. So if you'll turn with me to your problem set for lesson 17 in module 7 of your Learn book, you can follow along with me as I work these 4 problems out on the board and show you guys how to find perimeter of a rectilinear shape. Now, from the previous lessons, you guys have learned that in order to find perimeter, which is the total distance around a shape, we have to have all of the sides in order to be able to find what the total perimeter is. If we're missing one side, it's impossible for us to find what the perimeter is. We need to find that one missing side, or however many missing sides there are, and then we can add them all up and find the perimeter. Okay? So, let's get started with today's lesson. So, A, on your problem set, looks sort of like this. It's a rectilinear shape because we see that it's composed of 2 rectangles. Now, you'll notice that there is a cut line right there in the middle. I like to call that dotted line a cut line. We're going to practice adding those dotted lines or those cut lines in every rectilinear shape that we make. We want to be able to basically identify all of the rectangles that make up that shape. Because when we identify the rectangles, it helps us figure out what missing sides are, and eventually it will allow us to find the perimeter of that shape. So let's look at this shape really quick. We have this long side down here is 4. We have this side up here which is 2. We have this side right here which is the missing side length. And we also have this side right here which there's another missing side length. Then this top little piece right here is 2 centimeters and this side is 3 centimeters. So, if I have a rectilinear shape, I'm missing some sides, I need to find those sides before I can ever solve for perimeter. So let's see what we're working with first. Okay? So if I'm looking at this rectangle right here, in this part, I already know what this dotted line or what this cut line is. If I look over here, I see that this is 2 centimeters. And we know from previous lessons that opposite sides of a rectangle are the same length. So if I'm looking at just this rectangle and I see that this is 2 centimeters, then my cut line right here has to be 2 centimeters as well. Right? So, if I figure out that that's 2 centimeters, now I want you have to be very careful with rectilinear shapes. This whole entire side is 4 centimeters. So not just this part is 4, but this whole entire side is 4 centimeters. So let's see what we can find out next. These are kind of like puzzles. But let's look at this let's look at this next rectangle, the bigger rectangle. If I'm looking at this side over here, which is 3 centimeters, then that means the opposite side over here, which means this part that we don't know, plus my dotted line or my cut line, has to be equal to 3. So if my dotted line is 2, and I have a little bit more left up here, and it has to make 3, what do you think this side right here has got to be? You're exactly right. 1 centimeter up there. Because this 1 centimeter right here and this 2 centimeters together make a full side, which is the same side as this over here, which is 3. So we're almost done. Now, I'm just missing 1 additional side length. So let's go back and see if we can figure this out. Let's use this big rectangle once more. If I know that I have 2 centimeters up here, then the opposite side of this big rectangle, so from here to here, has to be what? 2. So this little part right here has to be 2 centimeters. And this is kind of like a number bond here. If this 2 centimeters plus something else over here has to make 4. So 2 from this part and 2 for this part right here would make my 4 centimeters. It's sort of like a number bond. So now if I know this, if I switch rectangles and I look at this rectangle, I start to see a pattern for this rectangle. 2 centimeters, 2 centimeters, 2 centimeters. This is a special kind of rectangle called a square. I have 3 of the same sides that are 2 centimeters. I also could look at this and say, okay, my opposite side has to be 2 centimeters of this rectangle because we found this out and we found that out. Now, here comes the tricky part. Because we have all of our sides, but now we have to figure out which one of these numbers do we add? Do we add them all? Or are there some that we don't add into our total? Let's see. So these, remember, perimeter is all the way around the outside of the shape. So you have to ask yourself a question. Is that 2 centimeters on my cut line on the outside of my shape? No, it's not. So I do not need that for adding up my perimeter. These two centimeters, these two 2 centimeters right here, make up this entire 4. I just needed to figure out what each piece was of this 4. So will I have to add up 4 and then these 2 as well? No. I got to pick which one I want to add. Now for me, since the 4 was already there, I'm just going to stay with the 4. And I'm not going to use these to add my perimeter. If I chose to use these to add my perimeter, I would no longer use my 4. Because I'm breaking apart that 4 centimeter line down here into 2 2s. Okay? Now, would I use this 2? Yes, I do use this one because it goes around the outside of the shape. And I also use that one because it's also on the outside of the shape. So my equation to find perimeter, so if I'm going to say P equals, or P is for perimeter, then I'm going to have to start down here. I'm going to say 4 plus 2 plus 2 plus 1 plus 2 and plus 3. Try to squeeze it in there. Might be a little hard for you to see. But I've added this 4, this 2 that we found, this 1 that we found, this 2, and then this 3. I'm adding up all the sides around the outside of my rectilinear shape. So now, let's add this together. A 4 and a 2 make, you got it, 6. A 2 and a 1 make 3, and this 3 and this 2 make 5. Now I can continue to add these. So 6 and 3 make 9, and 9 plus 5 equals what? 14. So P for a perimeter for letter A on number 1 is equal to 14. Okay, let's move on to B, because these get a little harder as we go. So B, if you notice on B, there's no cut line on B. So we need to make some cut lines. We need to see how many rectangles are actually here. Okay? So the first thing that I might want to do, now your cut lines could be different than my cut lines. But in the end, as long as you're very careful in solving for the missing sides, our answers for perimeter should be the same, even if we cut them differently. So let's look. I'm going to say I'm going to cut this just like that. So now I have 1 rectangle, 2 rectangles, and 3 rectangles. Now, there's an important piece of information that I have, and I cut this a specific way for a reason. I noticed that I have a 2 and a 2 here. So if I have a 2 by 2 shape, if I have a length of 2 and a width of 2 of this shape right here, then that basically means I have a square. So that means that from here to there, I have also 2 feet. Okay? And then that means from here, this bottom corner to the top, I also have 2 feet. Now, this is only 1 foot, so what would my cut line have to be to make this whole side 2 feet? Yes, it would have to be another 1 foot. So these two 1 feet, or these 2 foots right here, make up 2 feet. Now, the same thing is true over here. This guy looks to be exactly the same as this. But we're not going to just pretend like they look the exact same and we're going to write out the same numbers now. We need to actually figure out if they are indeed the same. So the first thing that we're going to do is, well, let's look at this middle shape right here. If we found out that that was 1, then that means this other cut line also has to be 1 foot. And if this is 1 foot, then what does this other piece have to be? Well, if I look at this, if I'm looking across here and pretend like this, if I was to close that in and make that sort of like an additional rectangle, then I could say, oh yeah, this is kind of like an invisible rectangle, so 1 foot over here must mean that this other solid line there was 1 foot. So this also was 1 foot. If I can get my... So I have a 1 foot and a 1 foot, and that makes this whole entire side, the cut line and this solid piece, 1 foot. Now, this was an important number right here. Why? Because it's actually this line right here, which is part of our perimeter. We were missing this line right here, which is part of all the way around the outside. This one, so this guy right here is one that we're going to want to count in the end, but we'll come back to that later. Okay? So if this is 1 foot and this is 1 foot, I can't really figure this out yet. I can't figure out any of those yet until I figure out some more information. So let's keep going. If I know that I have a 2 foot by 2 foot, looks like a rectangle, but a 2 foot by 2 foot means that it actually is a square because the length and the width are the same size. So if this is a square, 2 foot by 2 foot, that means that all the sides have to be 2 foot if it's a square, which means also from here to here has to be 2 foot. Let's put that guy on the inside. So now I figured out this missing side, and I don't have a missing side across the top because they've given me that it was 5 feet. But I do need to use this 5 feet to help me. If the whole side is 5 feet, and from there to there is 2 feet, and from here to here is 2 feet, then what? So I have 2 foot over here, 2 foot over there. How many feet do I need in the middle to make it 5? Well, 2 and 2, I have 4 so far. So how many more would I need to make the whole 5 feet at the top? I need 1 more foot. So if I put 1 foot there, now we should notice something more interesting about this center one here. It has 1 foot here on this cut line, 1 foot, 1 foot. So this is also another square. So this unknown down there would also be 1 foot. So now, we got to eliminate the things that we don't need for perimeter. Remember, perimeter is the distance around the shape. I don't need to count anything twice, and I don't need to count any cut lines that I've made when I'm trying to solve one of these rectilinear shapes. So let's eliminate the things that we don't need. I don't need this one because that was the length of my cut line. That's not part of the outside of my shape. So I do not need that one. I do not need this one because it's the same as that. It's not part of the outside of my shape. Now, this right here, this 1 foot on the bottom, is actually part of the outside of my shape. So I need to keep that guy in there. And so is this one right here. This one is part of the outside of the shape as well. So I need to keep this 1 foot. But what about this 2, this 1, and this 2? Do I need to add those? Not really. I just needed to break it apart so I could solve for this bottom, or for this piece right here. I don't need, this is again like a number bond. So I do not need this 2, this 1, or this 2 because all those together make up the 5, and the 5 foot is what I really need to add. So my equation, I have all of my sides. I have this 2 feet, 2 feet. I have 1 foot, 1 foot, 2 feet, 2 feet, and 5 feet. So let's create an equation for P, or perimeter. Perimeter is 5 foot plus 2 foot plus 2 more plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 plus 2. Now, one way, if you're having a trouble trying to figure out where you started or where you ended on your perimeter, then what I always like to do is just put a dot at the one that I start at. So if I started at 5, I'm just going to put a dot there. That way when I add up all of these sides around the outside and get back to 5, I know that I started there and I don't need to re-add it. Okay? So let's do some easy math. I think we can make it a little faster with this than we did over there for letter A. So let's look. Let's combine some of these smaller things first. So I have 2 plus 2, which is 4, plus 1 more, which is 5, 6, 7, plus 2 more, which is 9, plus 2 more, which is 11, plus 5 more. So what is 11 plus 5? 16. So P, or perimeter, equals 16. Oh, I think you might have caught me. What did we forget? We forgot our units again. So our unit here is feet. And feet are actually larger than in letter A when we were talking centimeters. So this would be a much, much larger shape if we were actually drawing it out to scale. So perimeter equals 16 feet of this shape. Now let's move on to C. These get increasingly harder, and D is actually the hardest one on your problem set. But let's work through C, because it'll help us with a little bit more practice before we get to the more challenging one that is D. So let's look at C. C, when I look at letter C, I see 2 rectangles. And I'm going to cut them just like this. I'm going to put my dotted cut line right there, like I'm cutting it into 2 rectangles. Now I have 2 very, very easy rectangles. I'm going to start over here because this one looks like I have a lot of information. I notice, before I actually get started, I actually notice that I have a missing side here, a missing side here, and a missing side up top. So I need to find those 3 missing sides before I can ever find perimeter for this shape. So let's look at this one. Because it looks like a rectangle. I have a width of 2 and a length of 4. So if it's a rectangle, then opposite sides, this missing side has to be what? Yeah, it has to be just like this opposite side. So it also has to be 4. Now, if I look across, my cut line is the opposite of this side of my rectangle, so my cut line is 2. Just like this side over here. Remember, you got to use your attributes from rectangles to be able to help you. Attributes from rectangles and squares really help you a lot with rectilinear shapes. So, knowing that opposite sides are the same can help me solve these very, very quickly. Now, the next part is looking at this next tall rectangle here. I notice it has a length of 6 and a width of 2. Now, if the width of 2 down here, I immediately know my opposite side. My opposite side up here has to be 2 meters. So now, I'm only left with this piece right here, this missing side. Now, it's part of the whole side. Now, the opposite side is a total of 6 meters right there. So that means this side over here, so this 2 plus this 2 plus something else has to make 6. It has to be the same as that opposite side. So I have 2 here, plus 2 more, so that means from here to here, I have 4 meters. So how many more meters would I need going up to make it to 6? I would need 2 more meters. So 2 more meters. So this 2 meters, plus this 2 meters, plus this 2 meters right here, make up 6 meters. Good job. Now, I have all of my missing sides. Now, I can try to start solving. But first, I need to eliminate the stuff that I know that is not around the outside of the shape. or things that I broke down like a number bond. So if I'm looking at something here, what is not on the outside of my shape? Well, my cut line is not on the outside of my shape. So I'm going to mark that out. I don't need that. I don't need this value right here to find perimeter. So now if I'm looking, this 2 is on the outside, 6 is on the outside, 2 is on the outside, this 2 is on the outside, this 4 is on the outside, this 2 is on the outside, that 4, that 2, and we're back to where we started. So I have eliminated everything else that I need. So let's create an equation now. Let's start with 6. I'm going to put my dot at 6, and I'm going to start there. So let's say P equals 6 plus 2 plus 2 more meters plus 4 plus 2 plus 4 plus this 2 plus this 2, and now I'm back to where I started at 6. Now, it's very, very important that you do not lose your place. When you're going around the shape, I usually just add one at a time, all the way around the shape, so I don't skip any. If you skip one, you're not going to get the correct perimeter answer for a rectilinear shape. So, let's see if we can add this together. Now, one of the ways that I like to add lots of numbers like this is I like to kind of find things that make 10. So I like to mark out things that make 10. So this 6 right here, and this 4 make a 10, right? And then I have 2, 4, 6, plus another 4, so these 3 2s make a 6, and then that 4, so these things make another 10. So they make another 10, and what am I left with? I'm left with a 2 and a 2, which we know is 4. So if I have 10 plus 10, that's 20, plus 4 more, I get 24. So P, or perimeter, equals 24, and let's not forget our units, meters. Now it's important with perimeter. Perimeter does not get square meters because it's not 2 dimensions. When you are finding perimeter, you are literally finding the distance or the length of something. In this case, you're finding the length of all the way around a shape. So you're not working in 2 dimensions, so you do not have to have square. You should not have square units. Square units are only for solving for area problems. Okay, let's move on to the hard one. Let's move on to D. Now, when I look at D, it's a little overwhelming at first, but it actually can become pretty easy as long as we cut it up and make it all into rectangles or squares. So I'm going to decide to do it sort of like this. I'm going to make one up here, and I'm going to make another cut line right there. So now I have 3 different shapes to help me. Okay? Now, the first thing that I do notice when I cut mine like this is, well, first of all, I need to find any missing sides, and I have one missing side right here. Do not know this missing side. But if I look at the other side of the shape, I also have a missing side right here, and a missing side right there. And those were kind of tricky because we didn't really see those to get started. But you have to make sure you identify every missing side. Now, I can start to solve, and I'm going to choose up here because I notice one important thing about this shape. I notice that it has a length and a width. Remember from the geometry, remember from the polygon unit and the quadrilateral unit, the length and the width are touching each other. They form a point. And when they're the same number, you have a square when it's a quadrilateral. So this right here is a quadrilateral, and it has a length and a width that is the same. So that means that this little piece from here to here is 2 yards. And that means my cut line also must be 2 yards because this is a square right here in the middle. Now, that cut line might help us later on, but let's continue to see what we can find. Let's see if we can actually work to solve for any missing sides. So let's see about this one first. I notice down here that I have a width of 2 and a length of 7. So this is a rectangle, and that means this opposite side, so this piece, my cut line, and this all have to make 7, just like its opposite side. And what that means, this side over here, this 2, should be the same as this. So we already know that this is 2 yards. We found one missing piece, or one missing side. So let's look at the next one. The middle one is kind of hard, because we're missing this side, but I don't really have just this piece right there in the middle. I have this whole side, which is 4. But up here, I figured out that this little section right here was 2. So if this little section was 2, what does this have to be to make that 4? You're right, it also has to be 2. So this 2 plus this 2 make up this 4. And I can draw that like a number bond if I wanted to. I can draw lines out to the 4 like a number bond. But now that we found this side of this middle rectangle, we now know our unknown over here, which is also 2 yards. Okay? Now we're only missing this little piece right there. Now this one is kind of the hardest one to find. So right now we know that this cut line is 2, so we're adding 2 plus something else to get this cut line right here. But we don't know that cut line yet. So we need to find out what this cut line is, and then it'll help us solve up here. So let's look. This cut line is part of this big rectangle at the bottom, and we know that the whole side here is 7, so that means this 2 plus this cut line plus this 2 should all add up to 7. So let's see what we got. We got 2 plus 2, which is 4. Now, 4 plus something has to get me to 7. So these 2 make 4 plus something else gets us to 7. So 4 plus 3 gets us to that 7 yards. So this 2 plus this 3 plus this 2 make up that 7 yards. So now we have our cut line down here. We can also say that this whole line from start to finish, including the cut line and this missing piece, has to be equal to 3. So if my cut line is 2, I need something else to get me to 3. You're right. I need 1 yard to get me to 3. So this 2 yards plus this 1 yard get me to 3 yards. Now, I've got all the sides of this crazy rectilinear shape. Now let's figure out what we don't need. So I don't need this cut line. The cut line is not part of the outside or the perimeter of my shape. It's not part of the outside. I don't need this cut line. So the only things I got left, this is definitely part of the outside. These are definitely part of the outside. But these 2 2s right here, I actually don't need either. Because I just tried to find out, I tried to break this whole side of 4 apart into 2 smaller units of 2s. And I don't really want to double count them. If I counted both of those 2s and that 4, I'm double counting that side. So I just broke it apart to help me solve, but my real side length is right there, 4 yards. So I have 2 yards, 2 yards, 4 yards, 2 yards, 2 yards, 1 yard, 2 yards, 2 yards, 2 yards, and 7 yards. So let's create an equation really quick. So let's say that P equals, and let's start, I always like to start at the biggest one. So let's start at 7. 7 plus, I'm going to go this way all the way around. 7 plus 2 plus 2 plus 4 plus 2 more plus 2 plus this 1 plus 2 plus 2 plus 2, and then we're back to our 7. So let's see if we can make this, let's see if we can add it all up correctly to find our correct perimeter for this rectilinear shape. Again, let's think of things that make 10. So I know that 3 2's, so if I pick out 3 2's, 2, 4, 6, those make 6, and I see a 4 that I can pair that 6 with. So 2, 4, 6 plus 4 more make a 10. And then I see a 2, 4, 6, 8, 9. So I can add those up. Don't quite get to 10, but I got 9. And then my 7 is by itself. So let's try this. So I got 10 plus 9, which is 19, plus 7 more. So what's 19 plus 7 more? 26. So the perimeter for this shape is 26 yards. So let's recap really quick. So when you're finding rectilinear shapes, there's a couple things that you want to make sure you do. The first thing is you should hunt for any missing side that's on the shape, because with a missing side, you cannot find the perimeter. The second thing you need to do is you need to cut that rectilinear shape into multiple rectangles or sometimes squares. So that you can use what you know, the attributes of a squares and rectangles to help you find out missing sides. So, and one more tip for you. Most of the time when you have a cut line, you're never going to count that as part of your perimeter because you're using that cut line to help you find other sides that are on the perimeter of the shape. But most of the time the cut line is not on the perimeter and you don't use it in your problem. Okay? So hopefully you guys have learned a little bit about rectilinear shapes and finding the perimeter of a complex rectilinear shape. Until next time, see you later.